Hello, so we are now gonna start the last part of 3.1. So again, 3.1 is analyzing polynomial functions. And so today we will be looking at absolute and relative extrema. So it's basically we're gonna be looking at the minimum and maximum, and there's just different ways to look at the maximum and minimum. So first, a turning point. We need to know what turning points are. So a turning point is where the functions, I'm going to erase that and rewrite that. So where functions change from increasing to decreasing or decreasing to increasing. Okay, when it does that, it creates, creating a relative, and we'll talk about why it's a relative in a minute, min or max. Okay. So let's go ahead and take a look at the next part where it says use the graph shown to the right to find the coordinate points. So let's look at relative maximums and minimums and then what the actual maximum or minimum are. So relative means that they're a maximum or minimum, but they're not the actual maximum or minimum. So we'll kind of look at that here. So I'm going to highlight this here. So relative maximum. What is a relative maximum? Let's look over here and take a look. So a relative maximum, here's a max right here. Okay, so relative maximum means that it's up here, but it's not the actual maximum, right? So an actual maximum, I did purple. So absolute maximum would be up here where it's actually the highest one. Okay, what about a relative minimum? So let's look at a minimum. So here, and so here is a relative minimum right here. And then for the last one, where it's saying the absolute minimum, well, these arrows of the graph go on forever. So there's not actually an absolute minimum. So no absolute minimum. Okay. If we were looking for an absolute minimum, though, we would be looking for the actual lowest point. And then the absolute maximum would be the highest point. So right now we've talked about what the absolute are. And now we're going to talk about what relative means. Okay, so let's look at it here. So again, these are absolute, meaning they're the actual highest one. And now let's look at relative. What does relative mean? So if we're looking at relative, we're going to be looking at just a part of the graph. So if we're looking at part of the graph, so let's look for a low point. So right here we said the relative minimum would be right here. That's because it is a minimum on the graph, but it's not the lowest point. So right here it goes from decreasing to increasing. So here's a turning point right here. So right here. So again, a relative minimum is a turning point created when the graph goes from decreasing to increasing. I'm going to shorthand that because I'm running out of room. Okay. So then a relative maximum would be a turning point created when the graph goes from increasing to decreasing. Again, I shorthanded that. Okay, so let's take a look really quick at just what points on here would be turning points. So I'm going to add a highlighter and do, let's say, green. So we're going to look at what just turning points are, okay? So a turning point is when it goes from increasing to decreasing or decreasing to increasing. So here it's increasing and then it starts decreasing. So right here would be a turning point, and then decreasing, increasing. So a turning point here, and then it goes increasing, and then it kind of goes constant, but so right around here, there's another turning point, and then increasing to decreasing, there's another turning point. So this graph right here actually has 4 turning points, okay? So let's just get rid of that there. So those are turning points, and the turning points create a relative min or max. They also help create the absolute max and mins. Let's look at an example. So use Desmos or a graphing calculator to graph this function here. I've already inputted the graph based on what I got from Desmos, and now we're just going to go and look for the domain, range, y-intercept, x-intercepts, and the end behavior. We're going to focus on that here, and then on the next slide we're going to look at even more key features of this graph. So remember, domain is the x values. So I'm just going to go ahead and kind of write that up here in parentheses. We're looking at the x values here. So what x values can I plug in? I will note that Desmos, when I copy and paste, does not show the arrows. There are arrows on this graph. It goes on forever up and down there. So for my x values, all the way to the left, I can go on forever to the left and forever to the right. So we have all real values, and I'm going to write it in interval notation. Remember, interval notation is from smallest to greatest, and then we can have the hard brackets or the soft brackets. The range would be our y value. So now we're going to look at the up and down line, the y-axis, and it goes on forever. For our smallest one, it goes down forever, and it goes up forever. So again, for our range, we have negative infinity to positive infinity. You will not always have negative infinity to positive infinity for your domain or your range. For this graph, we do though. Now let's look for the y-intercept. So where would the y-intercept be on our graph? And that would be where it touches on the y-axis. So here's the y-axis. Where does it touch? Right here. So our y-intercept is this point right here, which is labeled as 0, 1. So our y-intercept is 0, 1. And then our x-intercepts would be on the x-axis. So we have this one here, and then anywhere else right here, and right here. So this one has 3. So let's write that down. So we got the values of negative 2.4120, Then we have this one here, which is labeled as negative 0.1310. And then we had this last one here, which is kind of weird because this one right here is labeled here, and then this one is this point. The reason I know that is because I'm looking where y is 0. X-intercepts are where y equals 0, so it has to be this one. This one would not be your x-intercept because the y is not 0. So I'm going to go ahead and write that one down, negative 0.4270. So now I have my x-intercepts, and I want one more thing, my end behavior. And we can identify the end behavior by two ways. We can look at the graph, or we can look at our function. So I remember when we went over this that my my end behavior starts with as x approaches negative infinity. And then I'm also going to have to look at the x approaches positive infinity and what y does. So that's what I'm looking for. Anytime I'm looking at the end behavior, I can go ahead and just start writing this and then go back and look at what the graph is doing or what the equation tells us. So let's look at the graph. The graph, as I go to the left side of it, continues to go down. So the y is getting smaller, so it's going towards negative infinity. As I go to the positive side of the x-axis, it gets more positive. It's going up. So we have a y approaches the positive. Now, how could I tell that from the equation? Well, with the equation, I would be looking at the a and the n. We were looking at the leading term. The leading term is 1x to the 5th. So my n is odd. 5 is an odd number. And then a is greater than 0, excuse me. So we would be looking at our end behavior table graph, and we would look for n is odd, a is greater than 0, and we would get this right here. I'm going to go ahead and stop this video, and then for the next slide I'm going to start another video. I know that 3.1 is a lot of information, and so I'm just going to break it into different parts. So there's this video, and check back for the next one.